Well, hello. Welcome to the show today. This is a live design episode. If you haven't joined us for a live design episode before with us before, we have a ton of fun on this show where we just take some time and we look over some particular aspect of design. And this season, we've been doing something called a deep dive. So if this is your first deep dive with us, then we're kind of taking one topic and getting a little bit more into the weeds, or I suppose more into the seaweed if it's a deep dive. I'm pretty excited today because, well, it's Halloween if you're into that kind of thing in your parts of the world. So I'm feeling extra folly. And we have a lovely guest with me today. You may have seen her because she is a Champion of the Year winner. She's a designer, she's a 3D printing wizard. Danute Petrova-Nikolova. Danny, how are you today?
Hi, Jesse. I'm really good today. Thank you. And how are you? I hope you're doing well too.
I'm doing great. I'm pretty excited for today's episode because this is a topic that I don't really know that much about personally. So I am ready to learn something from you.
Yeah, that's interesting. Actually, it is a topic that a lot of people struggle with, and there is a little information about. And it's something that evolved with SolidWorks a lot in the years because the first time I faced this was, I think, 13 years ago. And back then it was real struggle. Now the things are much easier, and I really want to show you how to handle STLs in SolidWorks.
Yeah, I can't wait. So give us a little bit of a heads up, so I kind of know what you're going to be talking about today. But can you give us a brief, maybe overview of who you are? I gave you a little bit of an intro, but who you are and what we're going to be talking about today.
So I'm Danute Petrova-Nikolova, also known as Danny. I have a YouTube channel, The Workshop, and in the same time, I work in a company that produce really demanding measurement instruments for electronic measurement industry. Usually, these are very specific things that are made specifically for a customer, and kind of very interesting field I work with. But today I'm a bit away from design thing. It's about STL. I will talk about STL. There are many ways you can handle STL in SolidWorks, and if you want to succeed with your projects that have STL involved, which is the most common 3D model file you can find for free or paid, then this will make your life much easier.
Yeah, and I'm really excited about this because you alluded to it already, but a lot of people don't even know that you can work with STLs in SolidWorks at all. They might go to some other software or maybe right into their dedicated 3D printing software to try to work with things and not even realize that SolidWorks has some tools that you can use to work with these types of file formats, even as it is. Like you said, that didn't really exist before. So if you haven't been kind of paying attention to that space, then you might not even realize that any of these tools are there.
Yeah, you're totally correct. Of course, for some things, you still will need third-party software,
Sure.
but a lot of stuff, especially more basic ones, and even some advanced things you can handle in SolidWorks. With a good planning, with the right knowledge what to do, you can actually handle a lot in SolidWorks nowadays.
Yeah, very cool. Well, shall we get into it?
Yeah, sure. Let's see some things about. Okay, as I mentioned earlier, long time ago, in SolidWorks wasn't that easy to work with STLs, and even now a lot of people struggle because of one very simple thing, and that's the default import option of SolidWorks. If you go to the options, you can access it from here or from, I think it was from edit, no, from file. Okay. Page setup. No, it's not from file. Okay. I mean, you need the system options. I access it always from here, so I don't know the other workaround. Go to import tab here and change the format to STL. The default is solid body. And that's a terrible as default import options because what solid body is doing, it's translating every single triangle of your mesh to a surface.
Right.
And if you have a very complex mesh, even if you have a great machine, probably it will hang out, a crash, or I'm not sure if you still have a limitation. In the past, you had a limitation from 2.5 million triangles. But most of the cases, if you have a very, very complex mesh file, solid body will crash. So people are trying to import STL, it's not working, and they even don't know they have different options.
Yeah, that's a great tip right off the bat because, like you said, that's something that's a little bit buried. It's not an option that you're going to see right off the bat. So you would have to go into that little gear. Or were you looking in the tools drop down? Is that where you're looking for the tools options where you could get back into this dialogue too, right?
So there is another place you can also access the import for STL, but this is, let's see if I go to open. So this is my dialog to open some STL file. And for example, I click here on STL, and here you can also access the options.
Yes. Okay. Yep.
But these are some other options, and you will get confused.
Where you were showing it before, that's your defaults, right? This you can do kind of file by file.
Yeah, but are you seeing now that if I hit options now, it's not the same dialog?
Right. Yep. Okay.
Yeah, that's the other mistake, and this will get people confused. You have to choose that you would like to import actually STL.
That's another great tip.
So, and then here in the reference, not the references, and here options sometimes is missing. That's the other problem.
Okay.
Usually you will have options now and it will open the same screen, but for some reason it's not coming every time. So the best thing for me is before you try opening anything, you go to the options, import, select STL, and go to graphic body. Graphic body is the lightest way you can import STL into SolidWorks. You can have a look on it. And in many cases, you can even use it like this. Not always you need STL in your SolidWorks file to work with. Sometimes you need it just visually. So if you need, let's say, like this 3D picture, then use graphic body. The other way, the other option, the other time you use graphic body is actually when you want just to review what you're importing. So I will hit graphic and I will open, let's open something more complex like this dinosaur. And now we have it in SolidWorks. As you can see now, it imported really fast.
Yeah.
Because there is not real data inside. There is just preview. You cannot work with it, but you can see it.
Yeah, and just to be clear, so the default of solid body, that's assuming that you're working, most of the time we're working in SolidWorks, we're working in CAD data that's solid geometry, right? So it's thinking probably, okay, we're taking this STL in and we're probably going to try to modify it using CAD-like functionality, right? So that's why I was thinking originally solid body would probably make sense. But in our case, for these purposes, graphics body makes a lot more sense because we're just getting the graphics triangulated, tessellated data, right?
Right and wrong.
Okay.
So you can convert graphic body in solid mesh, not in solid body in the way it is.
The other way. Sure.
So the solid body is actually a very strange format, I would say, for STL, because who would like to have every single triangle as a face? I mean, you may want to do that for some reason, but usually when you translate geometry, you want it to look smooth, nice. Like I won't save that one. I will open another file, which is this stone. I will open this stone as mesh file and as a graphic. That's a very complex shape. It will be really hard to recreate this in any way.
Yeah.
So if I use solid bodies import, every triangle will be a face, but then it won't be smooth. And what we want to have this is as a smooth object. Then what you go is here you have a mesh modeling tab and you have convert to mesh body. Before using this, you can also use decimate mesh body, which will reduce the triangle count if you need that. If it's very complex, probably you would like to run through this operator first. In the case of the stone, I don't need to do that, but I will just show how it works. You can reduce by percentage or to a certain count. So I will just make it 5%. And when you're reducing the mesh count, the triangle count, go on small steps.
Mm-hmm.
It's a hard calculation. It's not easy for the software to do it. So if it's a very complex model and you want to reduce it with 20%, for example, don't type 20% there. Go on fives or one, depends how complex it is. Otherwise, you're risking your machine not to handle the calculation. In this case, it's not so complex. It can handle even 20, but I want to reduce it just a bit to show it. And then you hit calculate. And now we have less mesh triangles. And here the count has changed.
Now, do you have a target for what you're trying to hit when you're doing this, or is it just kind of by experience that you're trying to figure out? Like, are you just looking at the mesh itself and saying, okay, I can reduce it by this much, and I know that that's going to still get me what I want, or is there some number that you're usually looking to try to hit?
Depends. It depends what kind of geometry I have, because this stone is kind of simple. I can reduce it few times 5, and it still will be fine. But if I have, for example, a dragon, then even 5% can be too much.
Yeah. Okay. So you're trying to just reduce it by as much as you can and still retain the detail.
That's one of the reasons. First, calculation is harder. The other thing is you would like to see how it's after every step. Even now with this 5%, you can see that here the meshes are becoming bigger. And maybe if I go 3 times more with 5, I will damage the surface here.
Yep. Okay.
So once we are ready, we of course hit OK. We have now the new graphic body. It's new one. And then we go to convert to mesh. We select it. Now, there is one interesting option here, which is group facets into faces. This won't work for the stone because the idea here is to recognize different faces. If you have more straight faces and whatever, here probably I will receive an error if I hit it.
Okay, so this would be if they were like coplanar faces, it would try to group those all into one.
Yeah, like if you have a look on the chimney of the benchy, you have a wider area, smaller area, and you would like to have this grouped in different phases.
Okay.
Of course.
Danny, not to interrupt you here, but I see people logging in on the chat. We've already kind of gotten into the weeds a little bit. You also have a YouTube channel, and obviously we'll get to as much as we can get to in this episode as we can. And by the way, guys, we're live. So if you're in the chat, drop questions. You can ask questions for Danny too. But you also have a YouTube channel and a website. Can you talk about that real quick, just while we have people on the line here for more info?
Yeah, sure. Of course. In my YouTube channel, I'm trying to explain in the most simple language complex SolidWorks problems. Also, I have a playlist about STL, of course, and I have few playlists that can prepare you for some certifications of SolidWorks. And yeah, if you're learning now SolidWorks or you're looking for an inspiration, the workshop is the place to go.
Yeah, very cool. And like you said, there actually isn't too much information as far as the STL stuff. So you're a great resource to check out because you're so deep into this stuff. But you're a good resource, I guess, to go to if you want to learn this kind of thing. But again, as I'll mention, if you're here with us as we're live, drop any questions in the chat, and I will try to catch those. Or producer Sean, thank you for producing today. We'll try to grab those, and we can ask Danny as we go. Cool. All right. Sorry to interrupt. Keep on going.
No problem. So now we will just hit this OK and see what we have. A perfect, smooth stone, which is actually editable. And you can see because I reduced the mesh here, the surface is not very well, just so you can see it better. Curvature won't work on that one. I forgot. So, yeah.
You can see it in the lighting now. Yeah.
Yeah. This is of the reduction.
Now, in this case, I'm looking in the tree. So we start with our graphics body as far as our history goes. And then we've got an import underneath that. And I see we also have 2 different bodies. If we look up in the bodies folders there, we've got graphics body and now also another one. Okay. So that second operation that we did was what generated those.
Yeah, that's the imported one. If you go with the other import options, if we go again here and open, and I will go again on stone, maybe this time I will have luck. Nope. So again from here. The other two options, I say two because surface and solid body, they're almost the same. Just in one case, you receive a solid body, in the other surface body.
Sure.
If you import solid body, as I said, every single facet, every triangle is a face. That's really hard to work with, hard to import. But there you have this other option, which is create mesh bodies bounded by single faces. If you check that, and of course you can check this too, SolidWorks is automatically going for you from graphic to imported mesh body.
Okay.
And you will have a file which is just with imported mesh body without a graphic body inside. Let's make it.
So that's kind of automating that second step that we would have done.
Yes.
Okay.
And now you have imported mesh body.
Yep, but not the graphics body, right? I see. So we've just got the one, so it just skips right to the end of that process, I guess.
Exactly. This is now editable object, but there is something very, very important. With the standard import that you have, not the solid body with the triangles, of course, because solid body is creating a solid body. It's not imported mesh. In the case of imported solid body or imported surface, without the option that I just checked, it's going inside as a solid. But in this case, you have imported mesh body. You can see the icon is a bit different. So you can work with this. I can cut through it. I can extrude and connect something with it. And actually, I will just do it to show it. I will add a new sketch here. As you can see, I can attach 2 points. I can interact with that model.
Yeah. Okay.
The thing is that we will end up again with a single body, but it's still a mesh body. And one big downside of this is you can work like this. You will have SolidWorks file. You can combine it. You can export it afterwards as STL file again and use it for 3D printing. But you cannot save as a step file.
Okay.
It's not possible to save mesh body as a step file.
Interesting. Okay.
And here you can make fillet. You can interact in any way. Okay. And these are the basic import options which are coming with every SolidWorks. So solid body, which is translating completely every single face. Maybe it's good to, I have a powerful machine. I will be able to import it that way, just to show. So I uncheck this, and I will open the stone again. As you can see, start taking a bit more time. You have a normal imported model, but with a lot of faces. That's what you have. And if you have a very complex STL file, it won't work, probably.
Yeah, just too much data, right?
Yeah.
So that option would probably really only work in cases where you have a very simple STL that's probably already pretty geometric already that you wanted to do something with. But otherwise, your recommendation is basically go the opposite direction and then convert it backwards when you need.
Yeah. My recommendation is no matter what you would like to do with the STL, have a look on it first as a graphic. Because
that's a great way to just get your eyes on it, right? And see what you're even working with.
You can have a log to decide if your machine will handle it, if you would like to change something, and then you can just close it and open it again in a different way. But if you go with the graphic body, you can have a look as
Yep.
minimum.
Makes sense. Sean's got a great comment here, question from the chat. Is a mesh body the same as a point cloud, like from a 3D scan, for example? Are those two one and the same, or are there differences that we would need to know about in these cases?
I'm not sure. Actually, point cloud I have never worked with. But mesh body is something which is for SolidWorks. So this is the SolidWorks format in which SolidWorks is telling you you're working with half STL data, half mesh data. This mesh data, I think, can be also from point cloud, for sure.
Yeah, generally when I do scans, I will save as standard mesh files too. So yeah, a point cloud itself could be just the points, but generally a mesh is just connecting all of those dots together.
For sure, Cloud Point you can import with the other option, which is Scan to 3D.
Good point.
And that's if you really would like to work with STLs and you work a lot with STLs and other mesh, you have to do a lot of reverse engineering, then you definitely have to look in Scan to 3D instead of the standard import. Standard import, it's suitable if you need it from time to time, or if you need just a graphic object to visualize something in your model, like a very simple example, you're making interior design. It's hard to find step files of plants, for example, but it's easy to find STLs. And you want to put this plant as decoration, you don't have to convert it. You can keep it as a graphic body.
Yep, that's a great point. Gives you a lot more flexibility.
And it will be much lighter than if you have a lot of steps inside.
Yep.
Yeah. So these were the import options for the standard import. And let's go down to my favorite, Scan to 3D. I will just close these stones. And that's the bench, but we will go to it a bit later. Scan to 3D is add-in. So we have to go to the add-ins and activate it first. It's here. Mine is already activated. One of the mistakes a lot of people do, they activate the Scan to 3D. I did this same mistake tens of times. I activate Scan to 3D, then I go to open, and I expect when I choose the benchy or the stone again, it will open it as Scan to 3D. But no, you remember my Scan to 3D is activated and it's just opening with the standard STL import.
Yeah.
That's because it's an add-in. And to open it with Scan to 3D, you have to choose. And here's the point cloud who was asking.
Yep.
In Scan to 3D, you can import point cloud. And you choose, in this case, Scan to 3D mesh file. When you choose it, as you can see, everything disappeared. I see only the STL files. I will open this sphere. Now the mesh icon is completely different than what we had before. And we have the options of Scan to 3D. One place we have it available is here in the menu. And the other is just right-click on the mesh. What we usually start with is Mesh Preparation Wizard, which will guide us through different steps to prepare our mesh file. So first we see the number of faces. We choose what we want to go through the wizard because we may have more than one file inside. And we just go to the next step. This is for the orientation. Okay, the sphere is not so important how it stays, but you may want to adjust it in some other orientation. It can be automatic. You can select references or with numeric input. My advice is don't touch the mesh orientation, especially if it's more complex part, and move the part after you finish with converting.
Okay.
Because funny thing, I notice more complex faces are not giving the same result when converting in original orientation and after they're moved. Exactly the same face gives different result. And the correct one is when it was not moved.
Okay. Danny, this episode is going to be a great reference because even just this first section, these comparisons between these different methods, they all look very similar. So if you've never seen any of these options before, this is a good comparison between all of them of how you get to some, because even just visually in the tree, the icons look very similar. There are differences. You can tell which is which, but it is very good to know which options that are somewhat buried will produce different results. So this is great already.
Okay, nice. You like it. I'm happy. That's why I'm here.
Right?
So I really hope I will have enough time to share all the tricks.
Yep.
So we go to the next step. Here in this step, we have different selection tools that we can choose some areas from the mesh. If we have a mesh that need to be corrected, for example, scan data, you can delete faces from here.
Mm-hmm.
You can use either the brush, polygon selection, lasso selection, square selection. Interesting thing that I find out, because of course we know with control you add more.
Yep.
But what happened if you by mistake choose some triangles you didn't mean to?
Mm-hmm.
Then you go with Alt and click.
Yep.
And remove them.
Nice. Great tip.
So I won't delete anything. We will just go to the next step. And here is simplification in the scan to 3D. Again, here you have reduction amount is percentage or target mesh size.
Mm-hmm.
And the good thing is you can see it here quite fast. It's not calculating that much like with the other one. Very interesting trick actually is if you have a mesh that has errors, but I will show also this one, it's better to reduce at least with 1% the mesh.
Mm-hmm.
Otherwise, you may risk to go in never-ending cycle of repair, and it will come with new errors. Okay. But if you touch this one, you're forcing I suppose you're forcing the app to recalculate everything, and you are able to repair from the first time.
That's another great tip. Now, Danny, we kind of compared the ones at the beginning. What would you recommend using the scan to 3D method for? Or maybe you'll get to this in a moment, but why would you recommend using this method over just grabbing the other ones? Is it just for the file formats that scan to 3D allows you to bring in, or are there other benefits here?
Scan to 3D, it's easier to work with, has more options than the normal import. And I would recommend using that one when you need to reverse engineering. So you need a SOLIDWORKS data. When you don't need the SOLIDWORKS data, or you have a very complex file, like I said, like the dragon. If you have a dragon, it's not that it's impossible, but it's close to impossible to convert it to SOLIDWORKS entities. And in this case, better to use the standard mesh import and just convert to mesh body. But when you have some geometric data and things that can be converted, then it's better to use Scan to 3D because it has a better tool set.
That makes sense. So this is a much better route to go than to try to just put it on solid and get a whole bunch of faces that you don't need and end up with a mess, right? This lets you kind of have all of these tools at your disposal before you get to that step.
Yeah. So now I will go fast to the end. Okay. And go through the first screens, because this is just overview on how Scan to 3D is working. But there are more interesting things to share about this tool.
Sure.
Yet. So we are not changing the mesh size at the moment. This to make it smooth, change the smoothness. And here on this step, you can launch the Surface Wizard. Here you have two options. Automatic creation is recommended for very complex shapes that don't have a resemblance in SOLIDWORKS features. like the stone. For the stone, you have to go through automatic creation. But the guided creation will give you a choice of features to convert what you have. So now we will go to the guided creation. Here, if you have something symmetrical, you can split it by plane and just make one half of it. In this case of the sphere, I won't do that. And now it's calculating what kind of areas we have. It decided that we do have like 3 submeshes, but if I move this slider here, this will change. So to the right is more rough and to the left is more detailed. And you see we have a different colors coming here. So I will go completely to the right because it's one sphere, and I will go apply. And then next step. Now when I click, here I have what kind of face is that? And why I keep the sphere, because I know I have it.
Mm-hmm.
There are some additional settings, like for example, here is the radius. I may say that's not the radius, I'm quite sure is this one, and it will change it.
Mm-hmm. So that radius initially, it just guesses, right? It just interpolates between all the points and tries to get as close as it can.
Yes. And once I do this, I can click somewhere away. If I have more than one surface to convert, probably I will click somewhere away. You will see what is converted, and then I will see the rest faces that are here. In this case, we don't have any. So I just go next and close the surface wizard and do have a spherical surface based on the STL that we had. At this point, I can even delete the mesh. I don't need it anymore.
Okay. Now we had a question in the chat, and I'm not sure I totally understand what what they were referring to, but it sounded like they were looking to compare STLs and parametric, and this kind of would be that, right? So if you're bringing in an STL, then you're then building a parametric model out of the data that you brought in from the mesh file, right? So in this case, you have both. You could look at them side by side.
Yes, but as I said, with the standard import of the STLs, you're importing some data. And you have different types to translate this data. If you go with the mesh body is something in between. So it keeps the STL data, but integrated into SolidWorks. So you can work with it, but it's not quite SolidWorks feature. And it's not parametric. So you can touch points, what is converted, you can use the surfaces, but it's not quite there. That's the reason you're not able to save it as a step file, because it's not pure parametric model.
That makes sense. Yeah, and usually when it comes to scanning for any of the purposes that I've done, I don't have good enough scanners that I could do something like this. So generally, I'll just bring it in as graphics, leave it as graphics, and then model around it as a reference. So it does kind of depend on what you're doing, I suppose, too.
Yeah, that too. But mostly people would like to do something. As I said, first time was more than 13 years ago when I was working with STL data. And my work this was actually jewelry. And I needed to import that in SolidWorks. They were intricate, they were beautiful, they were amazing. And I needed to put hangers on them. So I needed to work with the STL file.
Yeah. That makes sense.
It's not always you can leave it just as a visual. That's why we have different types to import it and different types to translate it. Great. And as I said, when you need reverse engineering, you're going to scan to 3D. That was the very simple go through. But let's go to that.
We had another question in terms of formats, right? Real quick before we get to the next step. Any thoughts on using STLs, with triangles versus quad meshes, maybe OBJ or 3MF? Do you typically bring things in with one format versus another? Like a lot of other modeling softwares, you might model in quads. Is that useful when you then get into SolidWorks, or do you have any experience with that?
So actually, if we go here, go on to scan to 3D mesh, you can see all the formats it can import. So it's not just STL.
Yeah.
It's you have many different. You have object, 3ds, and whatever. STL is just the most common one.
Yep, that makes sense. And in my experience, if it's something that came from something that was modeled with quads, it gets imported as triangular meshes anyhow. At least from my experience. So
Yeah, when it's mesh, it's mesh. I mean,
Mhm.
it's just if it's one of the formats SolidWorks can work with, then you can import it and work with it. It's other question how complex is the mesh itself.
Sure, makes
Okay,
sense. All right, continue.
now the Benchy. It's quite a story. Around the Benchy anniversary, which was not so long time ago this year, I decided to make a video that I convert the Benchy in SolidWorks solid body. Here you can
Hmm.
see it's absolutely solid body. What I didn't expect when you look on the Benchy, except the hull, the top part looks quite easy. And looks is maybe the most important word. Yes, it's simple on the top, but when you start to convert this face by face, you have tons of surfaces. And at some point, everything gets so messed around. You have tons of planes because you saw probably that when you use Scan to 3D, okay, now this is already converted, it creates a plane for every single converted surface.
Sure.
So we don't want to count the surfaces here, right? But there are a lot. Even if you combine some, then it will be still a lot. So my first Benchy conversion was more than 12 hours.
Wow.
Wow. And I said, no, 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 that's not possible. I mean, come on, that's Benchy. There
Yeah.
should be there should be an easier way. There should be a better way. Uh,
Benchy is the benchmark. It should be faster.
the funny thing is, it was there was a guy in LinkedIn. Sorry, I forgot who he was, but he said I can convert this for 2 hours, and I said, "Go for it, please. Show me you can convert it for 2 hours." On the next day, he write a comment, forget about it. So yeah, the bench is quite confusing. That's why maybe the most important thing is when you open your mesh to plan based on what you have. So, and here is the real power of Scan to 3D. Unlike the normal mesh import, with Scan to 3D, you can split your mesh to different pieces. And I won't do that with the bench, of course. No matter that I have quite a powerful machine, let's not put it to the limit and risk crash. Uh, so I will just open another file, but as a Scan to 3D. Oh, by the way, interesting thing. I won't open it that way. Once your Scan to 3D app is activated, yes, if you go with the normal open, it won't open it in Scan to 3D. But if you drag and drop,
Huh.
it will open it as a Scan to 3D.
Interesting.
Yeah, that's
All right.
interesting.
No.
So,
So that just to recap, that happens just once you open one by selecting the scan to 3D options and open one, then it kind of sets it in the mode that you can drag and drop and it will work.
yes, when you activate the app, when it's activated, on drag and drop of STL, it will open it in Scan to 3D.
Interesting.
So, as I said, the real power of it was something that was puzzling me for a long time. I saw that I can divide the mesh, but I wasn't sure how to make it on separate meshes. Now I will show you what I mean. I won't go through the mesh preparation wizard. I will go directly to the mesh edit now. Oh, no, not mesh edit, sorry. Surface wizard. I go to the guided creation and the screen that is splitting in different colors. And one thing, the R&D, please, if you're watching, make something about the colors. It's really hard to recognize sometimes. Okay, now it's quite well divided, and I will leave it like it is. I will hit apply. And if I go to this step and just finish with the surface wizard, you will see that my main mesh is hidden, and now I have a lot of submeshes.
Okay.
These submeshes, if I want, I can combine. I can hide, so either separately. I will hide also this one. And what is left, actually, I would like to combine back in one mesh. I select them here in the tree, right click, and here we have merge meshes.
Mm-hmm.
As you can see, it's combining them. But they stay here as a submesh. So long time I was wondering how I make this submesh as a separate mesh. And the answer was extremely easy. You select the mesh that you want to take out. Right click and go through the mesh preparation wizard.
Ah.
Now, because we have some holes, it will ask to fill the holes, but I don't want to. If I want to fill the hole, of course, I will leave it like this and we'll go to the next step. But in this case, I want these holes to remain, so I just delete them from the list. I go to the next step, and here I finish. And now I have another mesh here.
Okay. I did not know that one. That is another great tip.
You know, this one I find out today.
Okay. So we're all learning stuff. That's what the show is for.
Fresh. For a very long time, I saw sometimes they're becoming a new mesh, sometimes they're not.
Yeah.
And I was wondering what is triggering that. And it's actually the mesh preparation wizard.
The wizard. Interesting. Okay.
Yeah.
I've learned that as well.
And once you have it like this, you can decide if you would like to continue to work with the mesh in one file. Okay, that's a simple mesh. Or maybe you would like to work with the mesh in two different files.
Okay. Yep. Like a different part file you're referring to.
Yes. Because if we go back to the benchy, that's a small hell here. As you can see the conversion.
Yep.
And when all of that is in one file, it's really complicated. But you can have it in more simple way. And here I have another file, which is bench only the whole.
Okay. Yeah.
And then I have another one, which is bench only the top. And because still this has a very big feature tree, what I can actually do with that is make a new part. And inside this new part, I can insert another part.
Okay. Yep.
Which is the benchy hull. I won't locate it. Here it is. And then I will insert another part, which is the top. Again, I won't locate it. They were built with the same origin, so they're like fitting together. What I have to do now is just go to direct editing, combine the two parts. And I have a lightweight benchy from where I can start working to build on top of it or to do something else with it. And every time I would like to change something to the parts, I can just right click and go edit in context.
Yeah, that's really nice. So it's kind of like a master model technique, but from mesh data.
Yeah.
That's really cool.
Otherwise, this will cause a big trouble if you go start building on top of that data.
Yep. Yep. You've got all of that complexity to work with, and then whatever you're trying to add on top.
Yeah.
That makes sense. We have a couple questions here. One about scaling, which is a good question. We haven't talked about that yet. So how do you deal with scaling on import? Is it one-to-one, or are there scaling settings that you need to know when you bring them in? What do you do about that?
That's a great question. Thank you who asked that. So I had a very interesting case
First
in
time on the
mid.
show, I think Brian said too. So he's right on it with the good questions.
Uh, there was a lady a long time ago that contacted me, and she said she had a problem to convert her STL file because it was giving in a very interesting error. The model size is smaller than 1 millimeter.
Okay. Yeah.
Great. In this case, we do have the luck to see that stuff there. But in some cases, actually, it's not visible.
Yeah.
And you just see the mesh here, and you see the error, and you see nothing else. And then you start wondering what's happening. And yeah, as long as you have a mesh in the tree, you probably have a file. And what you have to do is to click the mesh, right click, and mesh preparation wizard if you want to repair the errors first, or mesh edit is for scaling. You can move with mesh edit or you can scale. Okay, this is 1 millimeter. I would like to make it like 100 millimeters. Maybe. I don't know. And I hit OK, and I have it much bigger. Now, how much bigger I usually check with the sketch.
Hmm. Yeah.
But that's sometimes way too complex to deal with in SolidWorks. And as long as you have some slicing software, there you can scale it by to certain number. So size, whatever. Because maybe that's one of the weak points of SolidWorks. You cannot scale to size. You can scale by percentage only.
Sure. Yeah. So if you wanted it to be 6 inches tall or something, you wouldn't be able to dial that in quickly.
Yeah, like if I open my slicer, for example, and put exactly the same thing here, yeah. I mean, it's also small, and there I can scale it to a certain size.
By bounding box.
And the good thing is that from the slicer, then you can right click and replace it. Not replace it, save it as STL. So the wrong.
Okay.
Export as one STL. And I can, yeah, here I will replace some of the things that I had. And then I can import it in SolidWorks.
Yeah. And usually if your scale is off, it's off by tens or hundreds or thousands or something like that, right? It's usually some kind of conversion error, unit conversion error that comes in if you end up with it. At least I find if you end up with it way off. But that's a great tip too. Just throw it into a slicer and re-export it, and then you've already got it set rather than trying to fumble around with it.
Yeah. Now that's damage mesh. Remember earlier I told you for the loop with repair, repair, repair. So to correct mesh, you need a mesh preparation wizard. And if you don't simplify the model, and this particular dinosaur is doing that, it will repair the holes that it has at the moment, but it will come up with others. So my repaired mesh is with error again. It may fix after 3-5 loops, but I have had meshes that are not fixing at all.
Mm-hmm.
In that case, the magic thing that I said is simplify the model by 1 is enough. And now with the recalculation, you saw the pop-up window that tell me something. And I will just continue. I'm not touching anything else. I have again holes to fill. Yes, we fill that. And it's fixed. Very simple thing. But if you don't know it,
Yeah,
it,
right.
it may drive you crazy.
We've had a question in the chat about low poly art. Now, I would assume that that is something that you would probably design that way from the get go. But we did talk about using the decimate tool earlier. Is that anything that you've tried to do? Take an STL and try to create some kind of cool low poly art out of it?
I haven't tried that one, but yeah, you can do that. Maybe it's a better idea if you go in both directions.
Mm,
So if you make, I will use maybe again a sphere, because on the sphere you can see really well polygons. So you can go in both directions. When you go save as STL first, you can go to the options and make it really rough and choppy.
mm-hmm.
So you have here coarse, fine, and custom. I can increase the degree, increase the deviation. So make it something like this. And save it. Then for sure it's not rough enough, what I just saw.
Mm-hmm.
Even with the worst settings I was able to do.
Yeah, it's not designed to do that, right?
Yeah. Interesting. This time it didn't import it into Scan to 3D.
That's a clever idea to go both
Yeah.
ways, though. To basically crank the resolution down first, and then go at it again.
Yeah, when you import it, you can go again
Mm-hmm.
and
Sean
lower.
is producing and commenting in the chat at the same time, but he said I wouldn't have thought to run that wizard multiple times, and I would not have done that either. I did not even know you could separate meshes out like that by running the multiple wizard either.
Here it
Okay,
is.
there you go.
Whoa, that was too much.
Very low poly.
Extremely low poly. So that's a
One
nice one, I think.
Yeah.
Ah, even better. This we can fix later. And yes, you can run the wizard multiple times. Once you're ready, you can end on every step. Like,
Mm-hmm.
for example, that was almost perfect, but I don't like that here.
Yeah.
Okay, that's a bit weird. And what I can do is run again the mesh preparation wizard. And on that step here, I can delete.
Yep.
Once. Okay, I can delete them all. And then on this step, it will fix the hole.
Okay. Yeah.
Here
Nice.
it is. That's it. Once this is done, however, the easiest way won't be to convert face by face.
Mm,
Now you would like to save this as STL again.
sure.
And then you would want to import this as an object. So we go to the import options, STL, and here solid body is really useful because now when I open it, it will be automatically as faces. So here is a good use of the
We
solid.
found the use case for solid body, low poly art. Go figure.
Why? Okay, whatever. So that was weird. Maybe
That must have been the first
I
one.
didn't save the STL correctly. It seems.
Yeah.
Okay.
Yeah, I know what you're going for. Yeah, that's a good answer to the question. That's a great workflow.
Okay, so we went through a lot of use cases of the scan to 3D, repairing of the meshes, planning, dividing to pieces, how to make it separate meshes too. And now the question is, should you go through the guided creation for everything, or there are other ways too? And in the case of the Benchy, actually, as I said at the beginning, I will just show the Benchy mesh. I tried to go faces by faces. Okay, revolves, we have different things. But I end up with a lot of planes. The file became heavy. The geometry started confusing, no matter that the planes were hidden. Actually, I was catching the planes with my mouse. And it was complete madness. As I say, 12 hours, hell. Uh, However, there is a better way. Okay, we have a simple faces. So why not make a 3D sketch? And I will start adding points to every critical corner I need.
Hmm.
I will add a point here. Let's see, where's the outer side? And actually, with 3D Sketch, you can also measure some stuff on your mesh file.
Okay. Yep.
But let me do some points first. Like this radius, you won't model it like this. You will add it afterwards.
Sure. Yep.
This is how we work in SolidWorks, right? So, of course, I put the points there, but they are references, as I said. But you can measure the radius like this. We go to 3-point arc. 1, 2, 3. 1.28 is the radius.
Very nice.
And we exit the 3D sketch. Why we go to 3D sketch? Because only 3D sketch can snap to any point we want.
Yep. You can put all that information in one place without having to dealing with all those planes, right? And
yeah. So I will show just the first steps. I started with converting this one. And then later I will just show the top hull, the whole feature tree, because there is no point to convert everything.
Mhm.
So I go to the features. I need a reference plane. I should start from somewhere. And I will use a reference plane with 3 points. I will start from here, because from here on the top, it's straight. And from here bottom, we have some angle. And the best thing to do that is to start in the middle, in between. I make this plane, go to the plane, add a new sketch. And what I need is, it's rectangular, but still I will build it with relation to my points. So this point is here. This point is on the line. Okay, it's horizontal, so it's there anyway. And the last point was here. And then I will make a simple extruded pose in one direction up to vertex that we have. And in the other direction, I will make it just longer because we have a cutout in between.
Mhm.
In the other direction, however, I need a degree. And let's find it out. It's 5 degrees. And that one is ready.
Nice.
Then we have the cut extrude. We add here a new sketch. This one I will make just like that. And we make it up to vertex. And it's this one here.
Now, do you find yourself messing with the visibility of the mesh body at all, or do you just kind of do enough of it that you get used to it? I don't, like I said, I don't do a lot of this unless I'm working with a scan or something. So I find myself toggling it off or setting it to transparency, which sometimes could be even worse depending on what you're doing. Do you typically work this way where you have both showing, or do you kind of go back and forth too?
So sometimes I'm hiding it, but to be honest, I prefer to split it on smaller meshes, which I showed a bit earlier.
Yeah, that's a great tip.
So once I'm here, I can hide it. We had the 3D sketch 1.28 is the radius we have. But I did a small mistake. I don't know if you notice. So when I made the boss extrude, actually I used an angle, but this should be straight with that one.
Right.
And of course, that's very easy fix. I will just delete the face with direct editing, add patch.
Another great tip.
And here we have it. So this part is kind of ready. And like this, piece by piece, I built actually the hull. No, the top, not the hull. The hull is more complicated.
Yeah.
So there were some revolves, but again, I did the revolves by myself. The bench probably was the only thing that I aligned really to have the top plane in the middle, because I do have revolves here. And it's much easier like this.
Now, when it comes to something like the hull or something that's more free form, would you go through the wizard and try to match it up with some kind of B rep surface, or do you usually just go in and use the references and make your own loft, or try it both ways? You just have experience that what's going to work best in that scenario.
In this case, for the hull was the B-wrap surface, that for sure, but it required first to extract a very specific part of the hull to leave it as a separate face.
Yeah, that trick is kind of key.
Yeah, so, okay, let's go here. It's here. This is the extracted.
Okay.
However, once I finish with whatever I'm doing to keep the feature tree more clean, I was deleting the submeshes. But the truth is that what I did is first I make the top a separate mesh and the whole area a separate mesh. Then I split it into halves. And with a lot of painting by hand, I took just that area to be. Let's do
Just to isolate that. Right. And it's tricky too, because this also has some fillets on it. So the curvature just suddenly changes. Oh yeah. There you go.
Here we are. So if I hide that one, this is the extracted surface. And the other thing is here also you can see that I did build some of the faces with the help of 3D Sketch. I made the surface extrude for these two areas because it's much easier to draw it and extrude it instead of trying to convert that part. And this is the part with the planning. So split to as much pieces that are comfortable to work with, and then go in, even if in separate files. Now, if I have to do it once again, I will for sure divide the benches into different files.
Yeah, that is a great tip on its own. I am definitely going to come back to this episode myself the next time I need to do this and watch our episode back so I remember what to do there, because that's a great tip.
Okay, so I have no idea how we are with the time, but I
Yeah,
tried to cover most of the things I know already.
that's pretty well perfect, actually. I don't see too much else. Let's see here in the chat. I'm just taking a quick scan here, but we covered a lot. This was really useful. Like I said, this is not stuff that I do a lot, and it seems like there's a lot of people also saying the same in the chat. So it's really cool to see some of these tools that I don't use on a daily basis. Yeah, I think we've covered most of what I can see really quickly. So yeah, this is great.
Okay, nice.
Beautiful. Well, thanks so much, Danny. That was a great episode. Like I said, I'm going to come back and I'm going to watch this myself again when I need some of these things in the near future, because I know I will. And there are some great, great comparisons here between, like I said earlier in the episode, between things that look very similar in the software. So it's great to have this very clear distinction between those methods. So Eric is saying great show in the chat. He's always in the chat, 100% of the time. So thanks, Eric, for joining us. Thanks, everybody else, for joining us. Thanks mostly to you, Danny, for joining us for the episode today. I have a couple of things that I'm supposed to shout out, and what are they off the top of my head? We have Slug Me coming up, the largest user group meeting. Slug Me this year is crazy, absolutely crazy. You will want to tune in for that one. November 6th at 11 Eastern is when that will be going live on the YouTube channel. You'll definitely want to tune in for this. You can get a little bit of a sneak peek as far as what's going on here by the dinosaur eyeball graphic that Ian has made for this, but absolutely wild stuff going on for that. We have some very talented friends and coworkers involved in that one. So tune in for that. We also have another page on our website right now. It's very Halloween themed. We've got zombies versus structural simulation. So go check out this video. This is really cool that the guys put together. A fun little video showcasing simulation using the theme for the time of year, Halloween, and some zombies to see how strong the door would need to be to keep the zombies out, which is right where you want them. So that's about it for today. Catch those two items.